Hello everyone, let's look at strings. In this chapter, we will look at string manipulation. So we will learn the basics of how strings work and how we can create them by hand. But the main focus is going to be on regular expressions. Now, regular expressions can be very useful because strings usually contain unstructured or semi-structured data. And regular expressions are a very nice way of describing the pattern in the strings. Now, the first time you see regular expressions, it will look fairly complicated, but the more you work with it, the better you will understand. Okay, so let's take our tidyverse library and let's look at some simple examples. So we can create a string with either a single quote or double quote. And unlike other languages, there's no difference in this behavior. I would recommend always using a double quote unless you want to create a string that contains multiple double quotes. And if you forget to close a quote, you will see the plus sign, which is the continuation character, like this. Okay. To include a literal single or a double quote, what do? You can use a slash to escape it, like this. So if you notice, we can use a slash to escape and a slash to escape. And that means that if you want to include a literal backslash, you will have to double it up with a double backslash. Let's take an example. Like this. Now do remember that the printed representation shows the escapes. So the printed representation of a string is not the same as the string itself. So if you want to see the raw content of the string, you will have to use something called write lines. Write lines of x, and this will show you the slash like this. There are a handful of other special characters, and the most common one is a backslash n, which is for new line, and the backslash t, which is for tab. And you can see a complete list by requesting help. Now, sometimes you will also see very complicated strings like this. Let me give you an example. This is a specific character, which is a mu, which is a statistical character we are using. If you want to combine multiple strings that are often stored in a character vector, you can do it using concatenate, something we've already seen earlier, like this. Now, base R contains many functions that allow you to work with strings, but we will avoid them because they can be inconsistent and they can be hard to remember. Instead, we will use functions from string R, and these are more intuitive names and they all start with str underscore. For example, if you want to find the length, we can simply write str underscore length like this. It tells me the length is 80. Now the common str underscore prefix is very useful because typing str will trigger autocomplete. That means when I write str and underscore, you see there are so many different functions available. And I can see all the different functions like this. We can use str underscore c to combine things, so it becomes xy. Obviously, we can even use it with more than two, so we can use it with x, y, and z, and that gives us a result like this. If you want to use a separator, you can use the SEP argument like this. That will separate them. And like most other functions in R, missing values are contiguous. So if you want to print them as an NA, you have to use str replace NA. Let's take an example. like this. So as you saw, str underscore c is vectorized and it automatically recycles shorter vectors to the same length as the longest. Let's take an example like this. The objects of a length 0 are very quietly dropped, and this is particularly useful when you use it in conjunction with if. So let's take a simple if statement where we will say that the name is Hadley, time of day is morning, birthday is false. We're concatenating good, the time of the day which is morning, and I'll say that if the birthday is there, then I say and happy birthday, otherwise I do not say happy birthday. So if you notice here, when I run this, it simply tells us good morning Hadley. It doesn't show us and happy birthday. To collapse a vector of strings into a single string, you can also use collapse, which is like this. Right. Now let's come to something very important, which is what we call as subsetting. We can extract parts of a string by using str underscore sub. Like this. So we have three right now, apple, banana, and a pear. If I do a subsetting, it only gives us APP, PAN, and PEA, which are the first three characters. Now do remember that a str underscore sub will not fail if the string is too short. It will just return whatever it can find. Like in this case, we try to return 5 characters, but we only have 1 character, but that's okay. It will not return an error. We can also use the assignment form of str sub to modify strings like this, which is str to lower. All right. The next example I want to take is with regular expressions. Very, very important topic. So please pay a lot of attention to this. If you want to read a little bit more about regular expressions, simply type regex, and as you can see, it's just a sequence of characters for a search pattern, and it works on different programming languages. So you have it on R, you have it on Python, you have it on even Excel for that matter, you have it on Java, JavaScript, you have it on C Sharp. So regex primarily are used to describe patterns in a string. And now they can take a while to understand, but once you understand them, you will find them extremely, extremely useful. So to learn regular expressions, we will use strview and strviewAll. And these will take a character vector and a regular expression. So let's take some examples. We'll take a very simple one to begin with. So I'm concatenating apple, banana, and pear, and I'm searching for an. So it tells me that an will only appear in this banana, which is an, like this. The next step is in complexity, which is by adding a period. Let's take an example. If I add dot a dot, it means it will only search for ban and then bar, because in these two cases there is a character that is before and after. But what if the period matches any character? How do you match the character period? For this, you need to use an escape to tell the regular expression what you want to match exactly and not use its special behavior. And like we did in strings, regular expressions also use the backslash to escape the special behavior. So if you want to use a period, you have to use the regular expression backslash period. But the problem is this will create an issue. We use strings to represent regular expressions, and the backslash is also used as an escape symbol in strings. So to create the regular expression, we need to do two backslash and a period. So I know that's a little complicated, so let me just explain it with an example. So we need a double backslash like this, right? And the expression itself only contains one, and this is what will tell R look for an explicit period like this. We have a double backslash followed by a period. And what will this search for? This will search for um, this one, A period C. This is the only match that is found. So if the backslash is used as an escape character, how do you match a literal backslash? Obviously, we need to escape it, and we use a double backslash. So to create the regular expression, you need to use a string which will also need to escape the backslash. That means to match a literal backslash, you need to write 4 backslashes. So I know that sounds very crazy, but that's how we do it. So let's take an example. And how do we do this? For this, we have to write 4 backslashes like this, right? This will only search for that backslash between A and B. All right. Now, let's continue and come to anchors. By default, regular expressions will match any part of a string, and it is useful to anchor the regular expression so that it matches from the start or the end of the string. And there are two characters we use here. One is a hat like this, and the other is a dollar sign like this. The hat will match the start of the string, and the dollar sign will match the end of the string. Let's take an example. So in this, it will only search for A, which is the first letter of the fruit, which is only in apple. And if we use $8 like this, it will only search for the last one, which is the second one, which is banana, because A is the last character here. Now, if you want to force a regular expression to only match a complete string, you can use both of these, hat and the dollar both, right? So this is how it will look like this. So we have a hat in the beginning and a dollar at the end. And what will this search for? This will only search for apple and not for apple pie and for apple cake. Okay, now let's come to character classes. Now there are a number of special patterns that match more than one character. Like we have already seen the period, which matches any character apart from a new line. There are 4 other useful tools. This is D, S, we have ABC, and then we have hat ABC. So what do they do? The D matches a digit, so this one will match a digit. S will match any white space, which is a space, a tab, or a new line. The ABC will match A, B, or C, and the hat ABC will match anything except A, B, or C. Let's take some examples. So if we look at this, right, we're looking for a literal character that normally has a special meaning in regular expression. So when I do A period C, what is the result that is coming? It will only show me the second one, which is A dot C. Let's look at one more. If I look at a period and an asterisk and a C, it will only search for A asterisk C. This one. And one more example. If we look at a space like this, it will only search for the last one, which has a space between A and C. All right. Let's come to repetition. Now, this is the next step which allows us to control how many times a pattern has matched. So in this, we use a question mark, which is 0 or 1. The plus is 1 or more, and the asterisk is 0 or more. Let's take some examples. Let's look at this one. Now, in this, it will identify this part for me, the CC, right? But why is it only giving me 2? Because we are specifically searching for 2, right? So that means 0 or 1. Let's take one more example. If I make this as CC plus, then it searches for all the 3, which is CC and C. And let's look at one final example. So if I say CLX plus, what does it mean? It means that we're looking at C, CC, LXXX. That means, sorry, starting from CL and then XXX, because we are searching for X appearing 1 or more times. We can also specify the number of matches precisely. Let's take an example. So in curly braces, this 2 is the n that we are writing, which means it is exactly n. So in this case, it will only show us CC like this. Now we can do one more example like this, which is n followed by a comma, which is 2 followed by a comma, and this will give us all the 3, which is these 3, which is n or more. And the third one is comma 3, which means we are doing between n and m, which is between 2 and 3, which will give us ACC. There is a term here which is called greedy. This means that by default the matches are greedy and they will match the longest string possible. And we can also make them lazy, which means we want to match the shortest string possible by putting a question mark after them. So this is an advanced feature, but it's good to know how this works. We're putting a question mark here, and if you notice, despite the fact that we have given it 3 because it was between 2 and 3, it will only give us CC since it is a lazy match. All right. And let's take one more example. So if I'm doing this one, it will only search for CL, not for CL XXX because, sorry, yeah, not for CL XXX because it only searches for the first instance where it is found. Now let's come to grouping and back references. So earlier we have seen how we can use the parentheses as a way to disambiguate complex expressions. And parentheses also create a numbered capturing group. So 1, 2, etc. And a capturing group stores the part of the string matched by the part of the regular expression inside the parentheses. Let's take an example so that it is clear. So if I write it like this, what does it mean? So if I have certain fruits with me, so I'm just creating a list here. Like this. When I am searching for the specific pattern, what does it mean? It means that it will search for the repeating pattern. So this is AN, AN. If we search for COCO, if we search for CUCU, if we search for JUJU, if we search for PA, and if we finally search for AL, right? Right. Now remember that you have learned the basics of regular expressions, but in real world problems, these can be very, very complicated. And there are lots of reasons why this is important. Maybe you want to determine which string matches a pattern. You want to find the position of match. You want to extract the content of a match. You want to maybe replace the match with a new value, or you want to split a string based on a match. Now remember, regular expressions can be very, very long and complicated. For example, this is also a regular expression. Now I know you must be thinking, what is this? This is so long. You know what it does? This basically allows me to be able to find if an email address is valid. And like this, you will find lots of examples available online. If you go to Stack Overflow, you will just find these examples readily available. So don't be worried if you see such long examples. It's just, a pathological example because, email addresses are actually very complex. And that's why, we have to do something like this. So I'm sharing a link here as well. And this link will basically show you how to validate an email address using a regular expression. And as you can see, it's a very complicated process. And if you scroll down, you can find the code here as well. Okay, let's look at detect. So we can also do detect matches like this. So it tells me true, false, and true. That means E is not appearing in the second word. It's not appearing in banana. All right. Now we can also look at some more examples. For example, how many common words start with a T and what proportion of common words end with a vowel? Right? Let's see. It tells me 65 common words start with this and with a T, and the number of common words, the proportion which are ending with the vowel is 27%. Now, when you have complex logical conditions matching A or B but not C unless there is a D which is there, something like that, it is often easier to combine multiple str underscore detect with logical operators rather than creating a single regular expression. For example, there are two ways to find all the words that don't contain any vowels. Right? So if you notice, these are two different ways. The first one says find all the words containing at least one vowel and negate. This is find all the words consisting only of consonants which are non-vowels. If you notice, when I do an identical, it says the result is exactly the same. And you can take a call on which one is better. We can also use str detect to select the elements that match a pattern. And we can do this with subsetting, something we've already seen earlier, like this, with a $sign. However, typically the strings will be one column of a data frame and you will want to use a filter instead, something like this. So it's an object df, word is words, and then when I run this, we get the result like this. We're also filtering the data that is ending with the X. Then we also have a count that we can use, which is very simple, str count. So it tells us how many times is the letter A appearing. It is also fairly common to use the str count with a mutate like this. We get the result like this. All right. The next example, I'm going to use something called Harvard sentences, right? So this is a collection of sample phrases. and you can have a look at this. So we will simply write the length of sentences, the head of sentences. So it tells us the first few sentences. But imagine that you want to find all the sentences that contain a specific color. So we first want to create a vector of color names and then turn it into a single regular expression like this, right? So we are first creating a list of all the colors, concatenating it, and then creating an object called colors match, which is basically creating a single regular expression. And now we can select the sentences that contain a color and also extract the color to figure out which one it is, like this, right? So has color is a subset where in sentences I'm searching for my color match, right? And the result comes like this: blue, blue, red, 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 blue. If you notice carefully, the str extract will only extract the first match. And we can see that most easily by first selecting all the sentences that have more than one match, like this. So if I show it to you, there would be these three sentences where there is more than one match. So there are two colors in each one of them. So we have blue and red, green and brown, and then orange and red. So what do we do here? We simply write more color match, and the result is blue, green, and orange. If you want to get all the matches, you can use str extract all, and the result will be like this: blue, red, green, red, and orange, red. If you use simplify is equal to true, it will return a matrix with short matches expanded to the same length as the longest, like this. Let's take one more example. The extract all, like this, is the same length. Let's also look at grouped matches now. So earlier in this chapter, we have spoken about how we use parentheses to clarify the precedence, and we use back references for matching. We can also use parentheses to extract parts of a complex match. For example, if you want to only look at the nouns that are appearing. Let's take an example. So my noun is like this, and the result is the smooth, the sheet, the depth, a chicken, the part, and so on and so forth. str extract gives us the complete match, and str match gives us each individual component. So instead of a character vector, it returns a matrix, and the result will be like this. I'm sorry. Why is this not working? One second. I have to put a H as well, like this, right? So we get a matrix as the result. Okay. Let's see what else I can show you. Let's do some simple examples. We can also look at replacing matches. All of this is very simple. Like here, we want to do a replacement, right? We want to replace the val or a specific character here. Like here, we are replacing the val with a hyphen, right? With replace all, we can perform multiple replacements by supplying a named vector like this. If you notice, in one single line, we have converted 1 to ONE, 2 to TWO, and 3 to THREE. And what else? You can also use str underscore split like this. It will split it into different words. This is similar to tokenization on Python. All right, let's look at some other examples. Right, so let me explain this as well. So when you use a pattern that is a string, it is automatically wrapped into a call to regex like this. So the regular call, basically it's a shorthand for regex. We don't need to write it, but it's being written sort of behind the scene. We can use the other arguments of regex to control the detail of the match. For example, this, notice that it gives us all the three. Sorry, it will only give us the first one, which is only the specific case that we are searching for. If you use ignore case true, then all the three will be found because you're ignoring the case. And you also have something called multi-line, which allows you to use the hat and the dollar to match the start and the end of each line rather than the start and the end of the complete string. For example, here you notice we can use the start and the end of each line. This is multi-line is equal to true. All right, let's see if there's anything else that I can show you. Okay, so if you look at this part, we can also write comments is equal to true, which will allow us to use comments in white space to make complex regular expressions more understandable. So spaces are ignored, and as is everything after the hash. So if you want to match a literal space, you will need to escape it with a double backslash. Okay, great. So I think we have done quite a lot. There are, of course, many other things that we can do in regular expressions, and I strongly recommend that you should practice what we have done in the lecture and also go online and look at other examples that are available. And there are lots of websites that give you these practice problems. And if regular expressions you feel is important to your line of work, data cleaning, then you should definitely have a look at them. Do remember that there are other ways of doing these things as well. So it's not that regular expressions is a must, but for more complex data cleaning, using regular expressions is something you should definitely be aware of. Maybe not at a very advanced level, but at least a basic idea of regular expressions. So that concludes our lecture. In the next lecture, we will look at factors.